Modern technology is built on visibility. Serial numbers, supply chains, cloud connections, digital fingerprints. Every device leaves a trail. But what happens when a machine is designed to leave none? This is not science fiction. This is engineering. And according to leaked documents, it was once a real project. Several years ago, engineers studying electronic waste streams in China noticed an unusual pattern. Specific components were being extracted from recycling facilities before formal processing. Not expensive parts, not rare materials, but functional components with very precise characteristics. High-torque motors from consumer appliances, power regulators from decommissioned servers, microcontrollers removed from industrial control boards. Individually unremarkable, collectively intentional. From an engineering perspective, the logic was elegant. New components are traceable. Recycled components are statistically invisible. Their electrical behavior is known. Their origin is irrelevant. By selecting parts based on performance, not identity, the system eliminated one of modern technology's biggest weaknesses, traceability. According to leaked internal analyses, the project focused on one core principle: functional autonomy. Not artificial intelligence in the modern data-hungry sense, but deterministic systems capable of adapting through feedback loops. No cloud, no updates, no external control, just sensors, logic, and physics. The device was modular by design. Each module performed a single, clearly defined task: energy intake and conditioning, signal processing and noise filtering, decision logic based on real-time sensor input, mechanical execution with minimal energy loss. This architecture reduced complexity, increased reliability, and allowed rapid reconfiguration. From a systems engineering standpoint, it was extremely difficult to disable. Thermal signatures were minimized using passive dissipation. Electromagnetic emissions were reduced through shielding and analog filtering. No wireless transmission meant no detectable signals. The machine didn't announce its presence, it simply existed and worked. One internal report allegedly concluded, "The system demonstrates operational stability beyond projected thresholds." In simpler terms, it performed better than expected. Too well. That's when the project became a liability. Because the more efficient the device became, the harder it was to justify controlling it. Its greatest strength was also its greatest risk: replicability. The design did not rely on proprietary chips. It did not require specialized manufacturing. Any sufficiently skilled engineer with access to discarded electronics could theoretically reproduce the system. From a policy perspective, this was unacceptable. A technology that cannot be regulated, licensed, tracked, or recalled represents a structural threat. Not because of what it is designed to do, but because of who could build it. Officially, the project was terminated. Documentation was classified. Hardware was dismantled. Teams were reassigned. But engineering knowledge does not disappear. It diffuses. Years later, fragments began appearing. Short videos showing machines built from scrap, exhibiting highly optimized mechanical behavior. Forum posts describing control systems that avoided digital complexity entirely. A withdrawn patent referencing adaptive modular hardware using reclaimed components. No confirmations, no denials. From a scientific standpoint, nothing about the device violates known physics. No exotic materials, no impossible energy sources, just efficient design, careful system integration, and ruthless optimization. That is what makes it unsettling. Modern technology trends toward complexity.
This device went in the opposite direction: less software, more hardware logic, fewer dependencies. It was designed to survive failure. Some analysts believe the original application was industrial automation. Others suggest mobile infrastructure or autonomous logistics. A minority argue it was a stress test, an experiment to see how much capability could be hidden inside ordinary waste. The truth remains classified. What is clear is this: recycling is not just environmental policy, it is a secondary supply chain. And supply chains shape power. This video is not an instruction guide. It is an examination of an idea that challenges how we think about technology, control, and innovation. When systems are designed to be untraceable, oversight becomes impossible. The most dangerous machines are not always the most advanced. Sometimes they are the ones built quietly from what everyone else throws away. Somewhere, right now, discarded electronics are being dismantled, not as waste, but as raw material. And the line between forbidden technology and forgotten technology is thinner than we think.